The purpose of our of this presentation is to focus on ALCOM and ALCOM carbon markets work in decarbonizing the rice industry in the Philippines. Essentially, I'll just quickly get into the background of ALCOM and ALCOM carbon markets. I'll quickly summarize the existing project we have, as well as some of the key benefits we're bringing by using biochar and combined heat and power systems to decarbonize the rice industry, focusing not only on rice mills, but just on creating a more circular economy. And I'll also end off with some potential research collaborations with the rice husk-based biochar that we're making, which we have kind of identified as a bit more unique than other types of biochar, largely due to its chemical properties. So with that, I'll just give a brief background about ALCOM and ALCOM carbon markets. So we were founded in 2020. We're headquartered in Singapore, ALCOM, and our focus is on basically collection, processing, and distribution of various feedstocks and finished products. So this is largely in regards to biofuels. So we're involved in the collection, processing, and distribution of waste oils, and we convert that into fuels for the transport sector. So over here, you could see that there's the image. We focus on creating sustainable fuels for the maritime sector, the aviation sector, and the road transport sector. And essentially, we are in the GHG avoidance sphere. And 1 year into it, we also did a strategic focus to shift to removal as well. And we started developing our biochar strategy and our biochar projects. And ALCOM Carbon Markets was founded in 2021. Largely a spin-off from ALCOM, and our focus is more on removals as well as other sorts of methodological developments. So the second picture over here is actually the rice husk-based biochar that we've produced, and that's actually some of the samples that we have. A quick introduction about myself as well. So I am the lead carbon project developer for ALCOM Carbon Markets, and I've been working for 2 years, largely in line with when ALCOM Carbon Markets was founded. Prior to that, I was in the oil and gas sector, so I've made quite a transition from liquefied natural gas to carbon removal and carbon avoidance. So a quick background on where we operate. I'm based in London, but as I mentioned before, we're headquartered in Singapore. We have an existing biochar facility in the Philippines, and we have project partners and affiliates based in India as well as in North America. So just as a brief background, over the past year, ALCOM has accomplished quite a bit. And I think the reason is because we stood on shoulders of giants. And over here, we have got quite a robust and quite an experienced biochar-related team. So we have Engineer Bilonio, who's a senior research fellow at PhilRice, and he pioneered some of the first low-cost, environmentally friendly rice husk-based stoves to sustainably generate power without black carbon emissions. We have Dr. Torres, who is our agronomist. He has a PhD from the University of Philippines, and he's affiliated with the International Rice Research Institute. His focus is on banana and pineapple plantations in Southeast Asia, and he has a lot of experience applying biochar before. We have Dr. Lampayan, who is our water management scientist, and he looks into water management for paddy fields. He is also affiliated with the IRRI, and he pioneered and conducted some of the first AWD, or the rice methane avoidance tests and programs, which was basically applied in the Philippines during the CDM era. So he also comes from quite a long legacy of application. And finally, we have Dr. Aboyo, who's also doing basically research for us. She is the director of research at the University of Negros, and she has a PhD in agriculture, and her research focus is on sugarcane plantations. So we've got quite a holistic team, and what we are doing, of course, is continuously doing farm trials to ensure that the biochar that we're producing from rice husk in the Philippines is actually having a positive effect on the soil. So I'll quickly give a brief overview of the Philippines. It's quite an agrarian economy with a lot of rice production. The picture that I have here is actually one of the fields that we have done our trials on. And just to give you an idea, it's quite a huge market. There is 20 million tons of rice, which is produced annually in the Philippines. That implies around 5.5 million tons of rice husk and anywhere between 15 to 30 million tons of rice straw, which is generated every year. Now, the issue about the Philippines is, and I presume most other agrarian economies, is that the majority of the rice straw and rice husk is either burnt off for energy purposes or just burnt off to clear the fields. Based on our discussions on the ground, we understand that when it's burnt off for energy, it's usually burnt off in an open air furnace at rice mills, or it's sent to a power plant where it's burnt off in a biomass boiler. But majority of it is just burnt off on the field because farmers want to clear their fields for their next plantation cycles. And this is usually quite a tight deadline. We see them do it within a week or so. So it is quite practical from their end as well. There is not any sort of system to collect it. As I mentioned before, the rice husks as well are commonly disposed, especially in remote areas. They're dumped at the back of rice mills, along river banks, or as we have also seen, they're just burnt on the roadside. So over here, we can see that in the Philippines, through biochar and through combined heat and power, there's a huge potential for carbon removal and avoidance. This is like up to 20 to 35 million tons per annum just of the carbon removal. I mean, this is of course assuming we take everything and we sequester all the carbon from rice husks, but of course, this is just showing the potential and not the actuality, but still, it highlights how much room for improvement there actually is in the Philippines. I'll quickly go through what we have currently done in the Philippines. We have an operational biochar facility. We call it Nuevachar, mainly because the project is located in the province of Nueva Ecija, and it's in collaboration with the provincial government. It is 8 tons per day of agri-waste throughput capacity. And by this, we're largely focusing on rice-related waste. So rice husks, producing all around 3 tons of biochar as well. The excess heat that we generate from this is directed towards an adjacent grain drying facility, which is also in collaboration with the provincial government. And we are involved with them directly in the distribution of biochar. So far, we have distributed biochar to more than 1,000 farmers across the Philippines. This is largely based in the province. And independent of the provincial government, we have conducted our own farm trials. And through basically the people that I'd highlighted at the beginning of this presentation, they've been instrumental in helping us conduct farm trials on rice, corn, onion, and sugarcane. Now, quickly moving towards the future of decarbonizing the rice industry in the Philippines. What we end up seeing is that by producing biochar, we are essentially doing 4 separate things, which are also quite interlinked. First is that we're replacing rice ash, which is generated in prodigious amounts, and it's usually just disposed of nearby since it's uneconomical to move. You obviously have biochar's agricultural yield improvements, which we have seen through our farm trials. There's an increased robustness of the soil, and there was a case of accidental AWD that was also done. And finally, it's also about adding value to the farmers in terms of agricultural yields, as well as increasing the robustness of soil, which also gives them comfort and protects them against what we're seeing currently in the environment, which is more extreme weather conditions. So the existing and future initiatives that ALCOM is promoting would include sustainable agricultural practices, and this is in collaboration with the Provincial Department of Agriculture, developing alternate wetting and drying protocols to manage methane emissions from paddy. Again, this is in collaboration with the farmers with whom we're providing biochar, and we're also trying to utilize other agri-waste and convert it into biochar with the help of the provincial government. So this is just a brief of our facility and the people actually that are working. We are our on-the-ground staff is completely local, and we're also as you can imagine, marketing our biochar locally. Over here, this is one of the first biochar trials that we did. And below there's basically the YouTube link that we have put on to just, it's a short documentary which just highlights Alcom's journey and how we have helped the farmers and their experience with using biochar. Since biochar has never been introduced in the Philippines before. So we're doing it for the first time for a lot of these farmers. So we're trying to break that mental barrier and provide them with a decent amount of comfort. Again, in the news, there have been a lot of developments. We have partnered with the provincial government. And over here, we show, it says that biochar shows promise as a sustainable soil enhancer. This is based on one of our onion-related trials. And this is, again, some of the media attention that we have received in the Philippines. Finally, the main focus would be around just decarbonizing the rice industry. And this is basically the crux that we want to drive towards. What we see now happening in the Philippines is more of a linear model, and we want to make it more circular. The linear model, and this is actually quite generous because a lot of the rice husk isn't even directed towards biomass boilers. But taking that aside, what essentially happens is that the rice husk goes towards a biomass boiler, or more often than not, an open air furnace that generates a lot of rice ash, CO2 emissions, as well as black carbon emissions. And eventually, the purpose of the biomass boiler is to generate electricity, but there's a lot of inefficiencies, largely around transporting rice husk from rice mills to power plants, which more often than not provide electricity back to the rice mills. And there are some quite staggering numbers with regards to how much electricity is actually lost in transporting it back. What we propose is a more circular model where we look at basically developing on-site power generation through gasification and pyrolysis, which in and of itself has lower emissions. And we also generate green power on the site for the rice mill, and we do this through a competitive electricity production on site from rice husk. And the reason we can do this is because there is minimal transmission loss associated with it. Biochar, of course, is the byproduct which we give to farmers at a nominal price. It is reapplied to the soil with Alcom carefully monitoring it, and that's how we're getting our results. We're seeing increased yields in agricultural land. So I think the first issue that we want to highlight is basically this switch to captive power from just generating power either through fossil fuels, or more often than not, it's co-fired power generation with rice husk and usually coal that's done in the Philippines. What we see with gasification and pyrolysis is that there is no smoke, CO2 emission is highly reduced, and black carbon emissions are very low. And through the solution that we are proposing, basically we are addressing the rice ash disposal issue, increasing power independence in a country where blackouts are common, helping farmers increase agricultural yields, and overall promoting sustainable agricultural practices. So the first part that I'd like to discuss is on rice ash disposal. So what we see is, I mean, I put here power plants are dumping it, but pretty much anyone that's generating rice ash, which is also occasionally a lot of rice mills also just end up dumping it because they have very little alternatives to do with rice ash. So basically power plants are utilizing industrial quantities of rice husk to generate power. Even the fraction that the amount of power that we're generating is still a fraction compared to how much they are doing, but we're still doing it in a more sustainable manner. The issue with ash essentially is that as you all know, it's very light, and therefore it becomes extremely expensive to transport it over large distances and to comply with the local rules and regulations of disposal. So more often than not, it is just dumped nearby. And essentially through our solution, we are just replacing rice ash with biochar. But more importantly, we are involved in responsibly distributing biochar to farmers to enhance the soil quality, as opposed to just arbitrarily dumping it wherever it's the most convenient. So we have the circular solution since the biochar is applied back to the rice farms. There is power independence as well. In the Philippines, there is a bit of a centralized power problem where power prices are quite high, but there is still a high degree of intermittency. with regards to power production and access to electricity. The transmission losses and thefts is also a huge problem. With our discussions with local authorities, the number that was said was roughly 30 to 40% of power that's actually produced in the Philippines is lost or is dissipated this way, which is quite staggering. The power plants are at a pretty high capacity given the thermal efficiency and the amount of power that they can reasonably generate. So with our solution shifting towards captive power, there is minimum transmission loss and also very little, if any, electricity theft. The prices that we're able to provide are competitive with that of the local grid. And there's energy independence and robustness against power outages, which is particularly important for the industrial sector. So, and of course, the main thing is that this power is generated through waste. So it is a green power solution in that sense. The third thing that I had mentioned was agricultural yields, and this is from the preliminary data of our farm trials. So since 2022, we have successfully conducted 3 farm trials and have 1 farm trial, which is currently ongoing. We are monitoring the short-term effect of biochar applications on paddy fields, onion plantations, corn, as well as sugarcane. And for paddy and onion, we've seen increase in yields of close to 20%, which was quite phenomenal. One of the reasons, of course, is that the soil is quite acidic in these regions. We measured it and the pH was roughly around 5 to 6. Overall, through increasing agricultural yields, you do end up decarbonizing the rice sector because your increase in yields is not associated with any fossil fuel linked fertilizers or any sort of CO2 emissions on that front. So essentially your paddy yield or your rice yield per ton of CO2 falls if you're increasing it through biochar. And finally, the last thing that we are doing, and this is actually quite a bit, is focusing towards other sustainable practices. We are looking to convince farmers to adopt other carbon avoidance and methane mitigation measures. As you can see, this picture over here is a brochure that we prepared by our team in the Philippines. And this talks about the alternate wetting and drying protocol that we're looking to introduce, and that basically we are in talks with farmers to get it introduced. Since we are already engaging with thousands of local farmers for the application of biochar, we are then moving forward with other sustainable agricultural practices as well. An interesting anecdote is that one of the first farmers with whom we actually did a rice trial had like an accidental AWD scenario where essentially with alternate wetting and drying, what you're meant to do is after you inundate a paddy field, you're meant to let it completely drain out until, and usually that is between 2 to 3 weeks before you reflood the paddy field. And this essentially causes a reduction in methane emissions during paddy production. Now, the reason I call it accidental was because there was a water shortage in the Philippines. And for him and his entire field basically didn't have access to water for almost 3 weeks. And even in that scenario, he noticed that the plots in which he put biochar was actually more robust and grew a lot faster than the other plots. And that gave us that was one of the key ticking points that eventually led us to pursue this in further detail and see how we might actually help farmers adopt AWD as well, but obviously in a more structured and a more scientific approach. This was, of course, accidental and it is anecdotal, but it was quite interesting to hear this experience from him as well. And as I mentioned before, we do have experts on our team to ensure that the AWD protocols are according to standard. We have a water scientist, and he has a lot of experience in AWD and running trials throughout the Philippines. So we're quite confident that we'll be doing the right thing here. Again, this is more around sustainable agriculture, and it's around carbon avoidance and removal through AWD. Now, the final aspect that I'd like to talk about is what Alcom is interested in exploring other applications for biochar. What we understand, and we've done like numerous tests on our biochar, and we are looking at novel applications of the rice husk-based biochar, and this is unique due to its high silica content when compared to other types of biomass-based biochars. Over here, I have another picture of our facility, and we had a couple of students from the Polytechnic University nearby who visited us, who just wanted to get an idea of how biochar is made, and they were doing some research on that regards. But just in general, we are quite interested and quite keen to explore opportunities with universities to conduct research and to also look at alternative applications of biochar, specifically focusing on rice husk-based biochar because of its unique characteristics. And we are quite open to collaboration and conducting research on other areas as well, perhaps exploring like, rice vinegar, bio oil, all sorts of other byproducts that we could closely look into together. So with that, I'm going to end the presentation. I think this will be online anyways, but these are the contact details if you want to reach out. And with that, yeah, open to any questions.
Thank you very much for this presentation. That's a change of topic, but I think it's impressive what Alcom did there. If you have any questions, write them in the chat, please. My first question would be that, so what technology are you using for the actual pyrolysis? Is that a third party or is it your own technology?
So this is our own technology. We're focusing on gasification during our initial proof of concept. This is just the rotary kiln gasifier that we have set up in collaboration with the engineers that we have. So we've been using that technology basically to not only focus on biochar production, but also to focus on heat, which we're supplying to the nearby grain drying facility.
Okay. So Thomas van Rossum was asking, what is the benefit of high silica in biochar? Did you find any specific?
So from what I understand, again, this is something that we're currently exploring, but from what I understand, the high silica does serve as quite a potent binding agent. So there have been talks about mixing rice husk-based biochar in maybe some sort of concrete, some sort of mixture where normally, as opposed to other biochar, you would need another binding agent along with the biochar. From what I've heard and from some of the research that I've read, this is quite an interesting application where using rice husk biochar bypasses basically this third product that you need. But we're still conducting research and we're still doing a bunch of trials, basically.
And then Agustin Miala was asking, how many tons of biochar do you use per hectare, and how often do you apply the biochar?
So, I mean, so far we have run like various tests running, ranging from the application rate would roughly be usually between 2 to a bit more than 5 tons per hectare. So far, there's only been one season, so we've only applied it once since 2022. But we are currently monitoring it, and we're currently going into our second season of application. But a lot of the places where we're applying it on aren't exactly the same plots of land. Some of them are, and some of them aren't. So we also have now we have 3 levels, 3 degrees of data points that we need to monitor.
And then Paul Anderson was asking, do you have an approximate analysis of your biochar, or any stability measurement? So how stable your biochar is? Do you know?
Currently, we do have some of the proximate analysis on it. I don't have it with me at the moment, but yeah, we did get it tested because we did want to make sure that it does qualify as biochar and that adding it to the soil would not have any will not have any negative repercussions as advised by our agronomist. Yeah.
Okay. I would have a follow-up question on Alcom itself. So, it looks like this is a successful demonstration. Are you planning to replicate that outside the Philippines as well, or any plans in?
Yes. So I think for us, the main focus is on utilizing a lot of agricultural waste to basically decarbonize industries using the success, building off of the success that we've had in the Philippines. And I would say the main focus over here would be, for us, we do have like experience and expertise in rice-based products, rice-based agri-waste. But for us, we have done tests on wood chips, coconut shells, bamboo shoots, all sorts of other materials as well. And they also produce quite good biochar. I would say probably be better biochar in terms of carbon sequestration, but the other benefits of that still need to be determined. But from our side, yes, we are quite keen on utilizing our technology as well as our expertise and applying that in all across the globe, basically.